slide video presentation content is introduction, power utilization, power delivery, challenges, VSN versus VRN, and objective.
Today now I'm going to talk about the wireless sensor network application in smart grid. Okay, first of all, a smart grid is an electricity network that can intelligently integrate the actions of all connected to it. Generators, consumers, and those who do both in order to efficiently deliver sustainable economics and serve electricity supplies. It uses sensing, embedded processing, and digital communications to enable the electricity grid to be first observable, which is able to measure and visualize. Second is controllable, able to be manipulated and optimized. Third, automated, able to adapt and self-heal. And the fourth one, which is finally, it is fully integrated, which is fully operable with existing system with the capacity to incorporate a diverse set of energy sources.
The different consumption area.
Power utilization. It used in home area network. Zigbee is suitable choice for hands. It provide the reliable wide area coverage and predictable latencies that are expected for smart grid. A typical application of WSN for smart grid is wireless network meter reading system, which can determine real-time energy consumption for the customer, as customer can download their archive and take it to meter reading through a mobile device. Smart grid system needs to provide benefit to both like customer and the utility, and the smart meter within hands perform as an interface that translates, summarizes, and aggregates data of power users and present it to the power utility. Specifically in area of high population density, the smart meter must be able to different smart grid nodes that belongs to each customer by collecting usage information through 5G and S. This is a wireless sensor network that can link the various equipment and a central power route.
Power delivery. Okay, power delivery is a wireless sensor network can be used in electric power system operation and substation automation. For example, sensor could be installed to monitor the delivery system and power use in the system, and sensor can be further classified according to their location. Wireless sensor network can also provide a feasible and cost-effective sensing and communication solution for the remote system monitoring system.
Power generation. A bulk generation plant may contain several generation units, and several hundred actuators may control fuel, air, and water flow to optimize heat rate, efficiency of the generator, control emission, and adjust generator output within each unit. Wireless sensor could be installed to monitor the generation system in power plant, and wireless HUD could be used to deploy sensor. Sensor that use IEEE 802.15.4 base radio transreceive can function for several years in HUD environment without requiring any external power. Example, wireless HUD can route around not only single but also multiply node failures. Therefore, each generation unit may measure parameters such as steam, temperature, and air, water, and fuel flow rate based on sensor. This information is fed into the data acquisition system in the power plant.
This slide will present the wireless sensor network. You can see the communication via Zigbee protocol stack, which is IEEE 802.15.4 standard. The lower power, low data rate, and Zigbee utilize 3 ISM band, 2.4 GHz, which is a worldwide, 915 MHz for North America, 868 band in Europe. Zigbee use 16-bit and 64-bit addressing mode. There is have a star, cluster, tree, and mesh topology.
The challenge of smart grid is complexity. Efficiency is a better telemetry, faster control, more robust control, embedded intelligent device communication, integrate communication, exchange computing capabilities, and security. The other challenges is reliability and exchange computing capabilities.
Wireless sensor network versus wireless relay network. By introducing wireless relay network, firstly, it will bring down the number of sensors in the network used. Next, it will also reduce the power of the consumption. The node failure can be easily identified. Next, the data of the desired lane or avenue can be easily accessed. Lastly, it also have low installation costs.
The objective of this project is to accomplish a wireless relay in communication between sensor and control area network and finding reliable link when next hope not fail in communicating.